Hi, and welcome to another Hopper on microcontrollers video. Hopper is a modern semicolon and curly brace language similar to Java or C#, garbage collection, etc., but designed to run on small devices. So it's a simpler language. So it runs on small devices like Raspberry Pi Picos and the like, and also on 8-bit microprocessors like the 6502. Anyway, this video is about the real-time clock drivers in Hopper, and I'll give a little bit more detail on those. So first, let's look at the code a little bit. So I recently implemented a couple of different drivers. So I've written, I targeted 3 different chips so that I could get enough variety of features to write a decent driver architecture. So the thing you most want from a real-time clock is the time and date. Of course, they all have that feature. And then some of these chips have 2 alarms, some have 1 alarm, some have the resolution of the alarms down to seconds, some to minutes. These alarms can all trigger interrupts so that you can put events based on an alarm. So you can, and some of them that go up to like once a month or once a year actually. You can have a month in the matching for the alarm. One of them has countdown timers, which are really nice. And then they're quite easy, a lot easier to use than setting alarms, depending on what you're trying to do with it. One of them has some non-volatile or battery backed up static RAM, also kind of handy, because these devices have a little coin battery. So even if you're running it on a battery like a LiPo battery, if you're changing the battery or you're changing the power supply, it's nice to have the coin battery there so that the time never goes away. And one of them even has a temperature sensor, and in fact that's the one where this is the higher precision one with the seconds. And I've got a board from Adafruit that I'll be using in my example today. So I try to make a generic interface that works the same way for all of these devices. One of the common problems with microcontrollers and the time is setting the time. So like in Arduino, for example, the convention is to bake it into your source code, and then when you upload it, it'll get it at the time of the upload, but it's usually just a little bit off. So I found another way to do it, which is this API here. So if you call this and you're running in the debugger at the time, it will ask the debugger what the current time is and set your real-time clock based on the time from your Windows computer. So it's within a second, and these things are only precision to a second anyway. So this is a pretty neat way of setting the time. I'll demonstrate it. You can set alarms, disable alarms. You can tell whether you can poll to see if the alarm was triggered, or you can set it up based on a delegate, a callback delegate like an event. Same's true for timers if it has timer features. One of them keeps track of when the power was lost, so it'll give you the date and time of when the power was lost. And like I said, one of them has temperature, and then they have static RAM. So let's go back to the demo. Let's look at the hardware. So this is now my convention for how you decide which hardware to configure. So first you choose your board. So in this boards folder, there's a whole bunch of boards. And the reason you choose your board is because it defines the features of your board and the pin configurations. So this will give you a compile time error if you try and use a feature that doesn't exist, like it has no SPI1, for example. So it only has SPI0. So if you try and use SPI1 on this Adafruit Feather, you'll get a compile time error. Then you include devices. So we're including 2 devices in this demo. We're including a very specific real-time clock, and it's the FeatherWing that's sitting on top of my Adafruit board. So in the middle of that sandwich is the Adafruit Feather RP2040, which is a Pi Pico compatible board. it's got a LiPo battery attached to it. So this Adafruit Feather has a LiPo socket, and a charger for it as well. So lithium polymer battery. And then this on the top is the Adafruit Precision RTC FeatherWing. And I've got a coin battery in there for the backup. And then the second device that I'm installing is this ThinkInk tricolor ePaper. And for the purpose of what I'm doing, it's not ideal because you don't really want to update these that often, and they take a long time to update. So, I mean, for a clock, you probably want an LCD or something like a TFT LCD, but this is what I have. So that's what I've used here. And then I need a font if I'm going to draw text. If you're not going to draw text, you don't need a font. But if you include a font, then suddenly the draw text APIs become available. All right. So I'm going to switch off optimization. I'm going to build, and then I can just step through this in the debugger and talk my way through the demo. All right, so I'm in the editor right now. This entire development environment running on Windows is all written in Hopper. The editor is written in Hopper. The debugger, which I'm about to launch, this is the debugger, is written in Hopper. Hidden behind the LCD is the watch window for this call stack and locals, and then this black area at the top here is the serial port. So all the shortcuts are on the menus. They're all Visual Studio shortcuts, so F10 to step. So let's start. F10, it says loading symbols, because we can put breakpoints in here, etc. Because of the layout of my desk and which way the cable's going, I've flipped the X and Y direction of the display so that it's upright. And with ePaper displays, the background and foreground are inverted compared to the normal. So your blank screen is white, so background is white. So this is a bit of configuration of the screen. Now we're going to initialize the real-time clock device, and that's all you have to do. You're done. And because these plug together as feather wings, you don't even have to configure pins because they're obvious. So if you go to this file, where's the driver? Yeah, it's on this line here. It's all default pins that are being set up. Control backspace to go back to where I was. And the same is true of the screen. So if we go and look at the screens, the ThinkInk here, it's got all the pins configured in there because you're plugging these boards together, so the pins are going to be predetermined for that display. Okay, so to initialize the display, we step over that. We should succeed. Now, we are running in the debugger currently. So let's step into this and see how this API works. So it says if we're not running in the bugger, breakout. We are running in the debugger. So get the time from this runtime get time gets it from the current platform we're running on. And then it's going to set it into the real-time clock. This is a little confusing. This date time here from runtime is getting it from the debugger. So it's calling across the serial port to get the time from the debugger. I'm going to F5 this because I want the time to be accurate. So I can actually just set a breakpoint there and go F5 to get there. Okay. And then, yeah, it's set the time from the debugger. Right. And we carry on and we'll step back out. That's to keep track of when we last updated. No. So we get the time. And what I'm going to do here is I'm lopping off the seconds of the time. So I'm only looking at the minutes because I don't want to update my ePaper that often. And I'm going to keep the time, just the string of what the last time was updated. So only update it when the minutes change. And date, I'll have the whole date. So my last time, let's show you what that looks like. So this is what the watch window looks like on the right here. Variables we're watching, current date, time, all that. And like I said, this thing has a temperature. Let's see what the temperature is currently. 28.5 degrees C. So that's the temperature came down. And then this is how we draw. So you only want to update the display once because it's ePaper and it takes a few seconds to update. So you suspend all updates to the screen, draw all your text, and then resume. So when we do resume, it's going to update the paper. So let's put a breakpoint there. We'll go through there. It's drawing all, it's quite slow when running in the debugger. Let's see why this is not getting to there. I would have expected it to be there by now. Oh no, okay, there we go. It's drawing a lot of pixels, so every little pixel for all that text is being drawn. Okay, so we're at the resume. Again, you can see the watch window here on the right, all the variables in your debugger. We did a diagnostic output here to the serial, which is all that info. So the time, the date, the temperature. Now, before I continue, I'm going to switch so we can see the screen, like that. I'm going to take off this breakpoint, and then just F5. And there we go, the screen's flickering, and it's updating. So you can see it takes a little while for these ePapers to update, which is kind of why you don't want to do it on every second. So I'm doing it on every minute right now, which is probably not that healthy for the ePaper. But, you know, this is a demonstration. I wouldn't actually really build a clock this way. Another thing I like to do is this heartbeat here. So this is the built-in LED on the device. And every 5 seconds, because it's going around this loop every 5 seconds, and then it's checking if the time changed or not. And then when it changes like that, it updates the screen. So every minute. So I'm going to Control C out of there. And I'm going to unplug it. So let's unplug the device, and it's got a reset button. So let's try that. See what happens. There we go. So it continues updating because it's running on the LiPo battery now. And we're at 17 minutes. And as I was saying, I use that LED on the back. Can you see it? It's off right now. So it should turn on. There, it's on now, the red. So it'll stay on for 5 seconds and then it'll turn off. So I use that built-in LED a lot as a heartbeat to say my app's still alive. So you can see that it's a good little diagnostic. And I really like the NeoPixel RGB ones because you can set them to different colors to tell you where you are in your program. Yeah, there we go. Oh, it's updated to 18 already. That's why it was taking so long. I was wondering why it was on so long. There we go. Now it's off. But it was updating to minute 18. And the temperature changed too, probably because I was holding it. Anyway, there you go. A good worked example. I will post a link to a code snippet on Gist, to a Gist on GitHub for the source code for this sample. The entire sample here is 50 lines of code, really. I mean, I put in some comments and spacing and made it a bit bigger, but there's really not much to it. And if you're using a device that I don't have a driver for yet, let me know, and I'll write a driver for it. It's pretty easy to write your own as well. You're just copying one of mine and seeing what's different and using the data sheet, but that's pretty much what I do too. But I do want to have more drivers for this so that it is this simple to set up an application like this. And of these 50 odd lines of code, most of it is the gymnastics around trying to make the text layout look pretty and scale it up like that. And, you know, it's really not much code here. Anyhow, thank you for watching, and take a look at the source code in the snippet in the link in the description.